Today we're going to be talking about solving inequalities. Your learning targets for today: I can solve a linear inequality, I can use set builder and interval notation, and I can write a linear inequality to model a situation and then solve the inequality. First of all, what is an inequality? Well, you've used these symbols before in previous math classes. Less than, which by the way looks kind of like an L. So a statement like 2 is less than 5, that statement is always true. Greater than, such as 7 is greater than 4, and you should be familiar with the symbol less than or equal to and greater than or equal to. So we'll use those symbols instead of an equal sign. So for example, suppose we have x is greater than 3. Well, think about what that means. What numbers are greater than 3? Well, 4 is greater than 3, 5, 6, 7, a million. But don't forget you also have the number 3.5 or 3.001. So when we want to talk about the numbers that are greater than 3, I'm going to put a number line and make a spot here for 3. And I want all the numbers that are larger, which I find those numbers to the right, and I put an open circle around the 3, and that's to signify that I'm not including 3, but I want to get really close to 3. For example, 3.0000001 would be greater than 3. Then we're going to just create on our number line, a line going to the right, have an arrow to show that it keeps going forever. And that would be my solution to the expression x is greater than 3. So for x less than or equal to -2, again, I'm going to mark a spot for the -2. This time I want to include -2 and all the numbers that are smaller than -2. So to show that I'm including it, instead of an open circle, I'm going to fill that in. That shows that I'm including -2. And the numbers that are smaller go to the left, and we'll put an arrow. When you solve an inequality, it is very similar to solving equations. So the first thing you want to keep in mind is you are trying to get the variable by itself. You're going to use inverse operations, which means if you want to undo addition, you're going to subtract. If you're going to undo multiplication, you're going to divide. So you're always going to do the inverse operations. And whatever you do to one side, you must do to the other. So those are exactly the same steps that we had for solving an equation. However, there is one big difference. Suppose you have the numbers, the expression, 3 is less than 5. Well, you know that's true. And what happens if you multiply both sides by 2? So you're going to have 2 times 3 and 2 times 5. So we get a 6, we get a 10, and 6 is less than 10. So that's still a true statement. But what happens if you multiply both sides by a -2? So if you have -2 times 3 and -2 times 5, you get a -6 and a -10. Well, now it's no longer less than. Now my symbol needs to go this way because -6 is greater than -10. So what that means you need to remember is whenever you multiply or divide an inequality by a negative value, you must flip the inequality. So that's true for division as well. Anytime you are going to multiply or divide by an inequality by a negative value, you must remember to flip the inequality. So let's try a first example. And in this example, we are going to solve the inequality 4y minus 3 is less than 5y plus 2. So I want to get the variable by itself. It doesn't matter which side, just like with equations. However, most of you will find it will be easier for you if you have the variable on the left. And so I'm going to stick with that process here. So I'm going to subtract 5y from each side. And I get -y minus 3 is less than 2. Next, I'm going to add 3 to both sides. And we get negative y is less than 5. Well, remember that this is like having a negative 1 times y. Well, I don't want negative y. I want just y. So I'm going to multiply both sides by a negative 1. So if I do that, remember what happens. This has to flip. So I end up with y is greater than 5 times negative 1 is negative 5. So this is my answer. So this was an example where I multiplied by a negative 1, and I had to remember to flip the inequality. So I'm going to go ahead and graph my solution set. I'm going to label the negative 5. This would be an open circle because I don't include the negative 5. And since I want the numbers that are greater, I'm going to shade the number line to the right. 2 common ways to write the solution to an inequality is set builder notation and interval notation. So I'm going to show you the set builder notation. First of all, let me remind you of our solution. We had something that looked like this. So for set builder notation, it looks like this. This is our set bracket, and we have our answer was y greater than negative 5. So we're going to have the set of all numbers y such that y is greater than negative 5. And that is set builder notation. The set of all numbers y such that y is greater than negative 5. So you can see why we like to have a shorthand notation for that. This line right here is the such that part. This is the set of all numbers y such that y is greater than negative 5. So this was the set builder notation. Interval notation looks like this. We want to go from negative 5. Let's think of this side as infinity. Looks like a sideways 8. This as negative infinity. So on a number line, if you are going forever to the right, you can think of that as going towards infinity. Forever to the left, negative infinity. So interval notation marks the starting spot and the ending spot, left to right. So we are starting at negative 5, but we're not including negative 5, and we signify that with a parenthesis. So that's the left side. And the right side goes to infinity because that's the direction our arrow went. So this goes on the right. And this is actually called interval notation. So let's try this problem. I want to get the variable by itself, so I need to undo multiplying by negative 0.3. So I'm going to divide by negative 0.3. Now, notice I just divided by a negative, so do not forget to flip the inequality. So we're going to have a negative 12 over 0.3. This flips. We get less than or equal to p. Now, you can use your calculator. Most of you would do that, but let me show you a really easy way to change this. If you are dividing by a decimal point, we can move the decimal over, which is the same as multiplying by 10 in the denominator. Do the same thing to the numerator. So I get negative 120 over 3, and right away you can see that that's negative 40. So that's a really easy way to do that. So we get negative 40 is less than or equal to p. Now remember that I said we usually want to have the p, or the variable, on the left-hand side to avoid confusion. So if you read this backwards, you would have to read it as p is greater than or equal to negative 40. And most people have trouble doing that. So imagine if you picked this up and you flipped the whole thing over and switched it to p. If you flipped the whole thing over, the sign would flip as well. So you get p is greater than or equal, well, not that, is greater than or equal to negative 40. On a number line, I'll mark negative 40. I am including the negative 40. And we want the numbers to the right. Set builder notation would be the set of all numbers p such that p is greater than or equal to negative 40. And interval notation, this time we're including the negative 40, and to show that, the left side gets a bracket instead of a parenthesis. So the left side is negative 40, and the right side goes to infinity. Infinity, we always use a parenthesis, because if you think about it, you can never include infinity.